So what do you remember? Anything about the division, how we handle a division problem? Anybody remember anything about it?
Once you multiply by like opposite of 3 plus 5i.
So we multiply by what? Yes, that's exactly right, Chris. We multiply by 3 plus 5i. Does anybody know the word for that 3 plus 5i? What do we call that, Lewis?
The conjugate.
It's called the conjugate. That's exactly right. So the conjugate, I think we talked about this the other day. The conjugate, I'll just use the definition. If z is a plus bi, then z bar, which means the conjugate, is a minus bi. So to get rid of this I, and that's our goal, we do not want an I in the denominator. To get rid of that, we are going to multiply the top and the bottom by the conjugate of the bottom. All right? So then it just becomes like a major FOIL situation. So we're going to FOIL out the top and FOIL out the bottom. And let's see what we end up with. So just FOILing carefully. Hopefully I FOILed correctly. And then what do we remember about I squared? -1. So this is really a -15. So I don't know. If I am on the right track, I'm going to have -9 plus 19i. And on the bottom, I'm going to have 34. Did I do my work? Did my math? Is that okay? Now, these sometimes simplify. This one does not. But if you can cancel out of all three, then you do. So if you had something like -8 plus 10i over 16, you could cancel a 2 out of everything and get that as your answer. But if this had been an 11, you would not cancel the 8 and the 16. You have to be able to cancel in all three spots. Do it if you can. All right, so this one doesn't. I'm done. Okay, everybody all right with that? Remember, our goal was to get rid of the I in the bottom, and we did by multiplying by the conjugate. Okay, so this is another FOIL. Would you agree with that? I know Mr. Miller made a huge deal about this last year because we get so mad when people just square that and square that. That's not how it works. It's always a FOIL. So 9 minus 3 halves I minus 3 halves I plus 1/4 I squared. Keep an eye on my arithmetic. I'm old and feeble. I don't know. What do you think? This is -1/4. This is 36/4. This is -6/2. Does that look okay to everybody? All right. This. Oh,
Should that be 37?
35 over 4.
okay, well, this becomes -1/4, doesn't it?
Oh, yeah.
Yeah.
And this is 36/4. Get a common denominator when you add fractions, right?
Could you just leave it at the 35/4?
Yeah.
Minus 3i?
As opposed to what? What would you want to do? Make it a mixed number or something?
Yeah.
No. We like improper fractions better. Don't mess with mixed numbers. It's okay if you do. I mean, it wouldn't be wrong. It's just one extra step that's not necessary. All right. This one sometimes tricks us up. We've got to remember that when square roots of negatives are involved, you must first deal with the negatives. So please do not multiply these together and say the square root of 24. That is not right. You can't do that. When there's a negative under the radical, that must be dealt with first. So I'm going to think of this as I root 3, and this one as I root 8. Now I can multiply these and get the square root of 24, but I also have an I squared. So my answer, this is -1, and this is 2 root 6. So I'm going to have -2 root 6 as the answer to the problem. When you have negative radicands, this number is called the radicand. When you have negative radicands, you have got to take care of that I first. Don't do any other math. Do the I first, and then. Which then kind of guides the way I do this next one. If I need to take care of the I first, I'm going to deal with that right now. So I'm going to have root 7 minus 1, is that okay? Minus 6 minus, oh, be careful, oh my. In chapter 6, we'll learn how to deal with i's under the radical. That I is not under the radical. I am sorry that I wrote it very carelessly. It's root -8i. That's what it should look like. Mrs. Ford, you can take the square root of I? Oh, yes, you can, and we will learn how to do that, but not right now. So that I is out there. Okay, so I have 6 minus this. This is what the problem looks like. Now, this I has to come out. So would you agree I'm going to have 6 minus I squared root 8?
Wait,
Which is going to become 6 plus root 8.
wait, I'm confused where the I squared came from.
There's already an I there. I'm pulling this one out. It's all multiplied together. That's I squared. So I have a root 7 minus 1 minus 6 minus 2 root 2, because I'm distributing this negative and the square root of 8 is 2 root 2. I can combine these, but that's about it. So root 7 minus 2 root 2.
On ones like that, is there a specific order that you want us to write them?
Nope, does not matter one bit.
How come that's I squared? Because you pulled out the negative, but on the other one, it would just, you have -8 over there and you pull it out and it's just I.
Okay, this one already has an I with it. There's already an I there.
Where's the I? After there's
It's in the problem. It doesn't matter. This is all multiplied. So this is the same as I root -8. You can put the I in
okay.
front,
Okay.
right?
The I on the outside, like Sabrina was just asking, the I on the outside of the root, wouldn't that make it like, because you took the negative out? Oh, never mind, okay, so it was okay, never mind.
Okay, now we've got a big problem here, but we can do it. What do you think we ought to do first with this? I would foil the top, yep. Now, are we gonna need to do the conjugate thing? Yes, but I just soon go ahead and foil the top and get that cleaned up. So 6 plus 2i minus 3i minus I squared. So what's that gonna be? Minus I squared will be plus 1 and 6. So 7 minus I, is that what I have on top?
Yes.
So now I'm ready to multiplied by the conjugate of 5 plus 2i, which will be 5 minus 2i. So FOIL away. Hopefully, it's FOIL, right? Cleaning up, what do I got? What's 2i squared? Negative 2, so I got 33 minus 19i. What's negative 4i squared? So I got 29. And no canceling, but sometimes you can. Alright? A lot of arithmetic, but it's not hard.
Missing one pencil.
Your sure tire is really not picking this one. Okay. This is a real mess. So let's clean up anything we can clean up. So can we combine the 5 and the negative 7? Yes. These parentheses aren't really necessary, are they? So we can go ahead and combine that. So we have negative 2 minus 2i. And then over here we have x minus 3 minus yi, if I just distribute that negative. Now, I want you to just use your common sense for a minute. The number on this side equals the number on that side. Complex numbers, like let's look at this one right here, for example. Complex numbers have two components. They have a real number component, like a plain number, and then they have an I component. If two of those are going to be equal, does it make sense to you that the real number parts are equal and their imaginary parts are equal? So in other words, if I say a plus bi equals c plus di, wouldn't you say, okay, but then whatever a is, it has to equal c, and whatever b is, it has to equal b. So if I look at this, I have a non-I part right here, a real number part right here, and a real number part right here. Would you agree with that? Those are the parts that don't have i's, and they must be equal. So therefore, x must be 1. Similarly, the I parts have to be equal. So this negative 2 must equal this negative y. So y equals 2. When two complex numbers are equal, that can only happen if the real number parts equal each other and the imaginary parts equal each other. That's the only way that they can equal each other.
So the x is part of the real number, even though
Miranda,
it's
does
a
it have an
variable?
eye on it?
Okay, so it's real if it doesn't have an eye on it.
Exactly. Yep, yep. Yep. Okay, P6, due Friday. That's it for that. That's done. Now we're gonna start P7, which is more challenging, but we can manage it, we'll get it. Alright, so we're gonna do a few of these without a calculator, and then we're gonna do some with a calculator. These are all inequalities. Alright? Remember, did we talk about absolute values from a limit calculus perspective before? No? Okay, we're gonna talk about it that way. We're gonna solve these problems a little differently than you did last year, and we're gonna solve it differently than like my CP class is gonna solve it differently, because you are all going to take calculus, and you are all going to have to be familiar with what this actually represents. Okay? So I'm gonna back up a second, and I'm gonna remind you that on the number line, if I say, okay, this is 4 and this is 11, and I ask you, what's the distance between those two? You will say 7. And how did you get 7? You subtracted, right? Now, Peter subtracted 11 minus 4. And that's fine. Could we also do 4 minus 11? Yes, as long as we put it in absolute value. So, distance on a number line, if we're looking exclusively at a number line, distance is the absolute value of the difference. If you're on a number line, you just subtract your two values and take the absolute value, and that will tell you how far apart they are. So, thinking backwards, every time I see an absolute value, I'm going to think, okay, there are two numbers on the number line, and this represents the distance between them. Now, be careful. Distance is a difference. So the two numbers I'm comparing are not x and 3. The two numbers I'm comparing are x and negative 3. Because isn't this x minus negative 3? Distance is a difference. You've got to have a subtraction. If you happen to have an addition, that's all right. Make it minus a negative. So my two numbers on the number line are x and negative 3. So here's negative 3. X, I don't know where x is. I'll put x out here. What do I know about the distance between negative 3 and x? That distance has to be more than or equal to 6. So if it is 6, then this number out here would have to be what? If we want to be exactly 6 units away, this number would be 3. I'll put a closed dot there since it's an or equal to problem. But what if x was this way? Well, 6 this way would be negative 9. Now, the two dots on my number line are exactly 6 units away from negative 3. But I'm allowed to be more than 6 away. So it's not just those two dots, it's those two dots and everything further than those two dots. So the answer to that problem is negative infinity to negative 9. Use a bracket on the negative 9. Or 3 to infinity. If you didn't know what I'm talking about, we get through all our examples and you still don't know what I'm talking about, you can always go back and do it the way you did before. But I want you to understand, it's just going to help you next year if you understand kind of what's going on here. You do not have to do the problem this way, but this is the way I will do all of them. Okay, I think it's pretty easy. I just put negative 3 in the middle of the number line. I counted 6 that way and 6 this way, and figured out where to shade. Greater than means shade farther out. Less than would mean shade in between. Not hard at all. All right, let's look at the next one. There's a couple of things that are a little bit, bothering me about this problem. What, do you think maybe we should just do right away? Subtract the 2. Yeah, we definitely want to do that. So let's subtract the 2. Now, I am completely anal when it comes to the position of my variables. I'll admit it. I like to have my variables first. It's my personal problem. I want you to go back to this for a minute. As long as I am in absolute value, does it matter the order that I subtract? So, I don't like the way that looks, so I'm gonna turn it around. Perfectly legitimate, as long as you're in absolute value. The order of the subtraction doesn't matter. What is still bothering me about the problem? That, I don't want that there. I need a plain X there, because I wanna know X is how far away. So I'm gonna divide everything by 2. Mrs. Ford, is that legal? Well, first of all, I wouldn't do it if it weren't legal. And second of all, if you think about it, I'm dividing by a positive 2. What is the absolute value of positive 2? 2. So does it really matter that I'm pulling it out of the absolute value? No, because it's positive. All right, have I done everything right? Am I okay with this point? Okay, so I'm gonna draw my number line. This says the distance between something and 3 halves. So this is this 3 halves right here. The distance between something and 3 halves is 3 halves. So that something could either be here or here. So this 3 halves right here, this 3 halves that way and this way. So if I go this way, what is this? 0. And what is this? 6 halves, which is 3. Those would be open dots this time, right? Because of the symbol in the problem. And once again, I want to be more than 3 halves. So I'm going to shade out from these 2 points. So what will my answer be after I do all that? Negative infinity to 0, and I'm using parentheses all around this time. Union 3.
So when, on the second line, when you have 3 minus 2x and you switch it to 2x minus 3, the minus sign won't stay with the 2x, as it's the difference?
Yeah, because 11 minus 4, 4 minus 11.
Yeah.
Yeah.
Okay, that's
Yep.
all right.
All right, one more of these, and then we got a different kind, it looks like. All right, so let's take a look at this one. Okay, what do you think about this? What would my mind? Absolutely, that's a positive 3. There's no problem with multiplying by it. So x plus 2 is greater than or equal to 9. Now, be careful, that's a plus, and it really needs to be a minus. If we're gonna do distance, we gotta have a difference. So, instead of using positive 2, I'm gonna use negative 2. That number is not part of my answer. That is the place that I start counting from. So I am going to say, I'm going to count 9 units this way, which will put me at 7. And 9 units this way, which puts me at negative 11. And since I want to be, again, one more time, more than 9 units away, I want this distance to be more than 9, I'm going to go out. So my answer is negative infinity to negative 11. Union 7 to infinity. So, one more time. This says to me, I can read what it says, absolutely, and all that, but what it says to me is the distance between something and negative 2 is more than 9. The distance between something and negative 2 is more than 9. And so I just counted on my number line. Isn't that easy? I think that's easy. Try to think of it like that. All right, that one's easy. The next one is different. It's just a different kind of problem. It's called a quadratic inequality. So of course we'll approach it differently. It's not an absolute value. Any thought on what we might do with this guy? This is a no calculator problem.
What was it?
Factor it.
Oh, that's what I meant.
What a great idea. I love it. I think that's the best way to approach this one. Now, does every quadratic factor? No. And if it doesn't, we'll have to use completing the square or the quadratic formula. But if it factors, that's always the fastest, easiest thing to do. So how does this factor? Minus 4 plus 3, perfect.
So fast.
Now, we're gonna go to the number line, just like we did before. And I'm going to put 2 open dots on the number line. Any guess as to where those dots are gonna be? 4 and negative 3. Perfect. If you solved this, if this were equal 0 and you solved it, wouldn't x be 4 or negative 3? So that's where the dots go. What were the zeros? Now, some of this is going to be shaded. There's 3 sections. There's this section, and this section, and some of it's shaded. Just like in this problem, this was shaded and this was shaded. So some of the pieces are going to be shaded. I just need to figure out which pieces it is. Some of you probably already have an idea, and it's probably right. But the official way to figure it out is, okay, pick any number other than negative 3 or 4. 2. 2 is in here. Would you agree with that? 2 is in here. So I'm going to check 2. Is 2 an answer? So I'm going to plug it in. And if I plug in 2, and I can go back to the original, or I can do it here. If I plug in 2, I get negative 2 times 5. Is negative 2 times 5, that's negative 2 times 5, is that less than 0?
Yes.
So that means negative 2. 2 is the number you plugged in, right? 2 checks, and since it checks, it means that's part of the answer. So the section of the number line, the whole section, that held the number you checked is part of the answer, because it worked. Now, what if you picked 5? What if you picked 5? Well, you would have 1 times 8. If you put in 5, is that less than 0? So we're not going to shade that section. What if you picked negative 4? What if you have negative 8 times negative 1? Does that work? No. So the only part of the number line that worked is the little open interval from negative 3 to 4. Now, when I said you probably knew, I was hoping you were making the connection. All of my, because I didn't plan very well, all of my absolute value examples were greater thans, and they all ended up being shaded where? Out. So when you have 2 dots on the number line, and it's a greater than, you end up shading out. When you have 2 dots on the number line, regardless of the kind of problem, and it's a less than, you end up shading in between. So what I did was just like formally check that, but that is kind of a rule. There is one exception to the rule, which we will have to talk about at another day. But for now, that's that. So we'll pick up there. Have a wonderful day. If I'm turning back homework, you don't understand why it's wrong, you need to come and see me.